Greater region, mount up.
All right, let's go. So this one's kind of a review from yesterday. So let's factor what we can and see if there are any holes in this. 2x and x. Minus 1 or plus 1. Let's see, where do we want the minus to go with the smaller stuff? So like that. All over this bottom one, we can factor out what? Yeah, we factor an x out of everything there. So if we factor an x out, then we're left with x squared minus 2x minus 3, which is a, is that unfactorable? No, that's good. X minus 3, x plus 1. Okay, so that one's a little different because we are going to have a factor of x in the denominator. What's that? Yep, so cross out the x plus 1. Yep, so Mr. Whiskers is eager to determine that there's going to be a hole right there, right? So if you cancel out two factors like that, that means there's a hole at x equals, what makes that 0 is negative 1. All right, now yesterday, or 2 days ago, I forgot to acknowledge the hole on my graph, didn't I?
Yep.
Didn't I?
Yep.
Yes.
Yeah. Okay. So, in order to not forget that, let's go ahead and find out where that hole in the graph is going to be. So, x value is negative 1. What's the y value going to be when x is negative 1? Just got to do a little substitution in here and determine what that value is going to be. So, there will be a hole at negative 1, negative 3/4. So, if we put some markings down here. There's going to be a hole wherever the graph is at negative 1, negative 3/4. So somewhere like right in there. Okay, any vertical asymptotes? Well, vertical asymptote happens when the denominator is 0. So that's going to be at x equals 0 this time, as well as x equals 3. So at 0, 3, because those are two values that make the denominator 0, we're going to have a vertical asymptote. So go like that, and over at 3 as well. Luke, be quiet. Horizontal asymptote is going to happen when, well, it depends on the degree, right? So in this case, the bottom degree is bigger than the top. So that means that it's going to, as the end behavior, it continues, it's going to go to 0. So there's going to be a horizontal asymptote at y equals 0. So that's going to be the axis. Okay, so we have those three asymptotes we're dealing with. X-intercepts, we're going to have 1. It's going to be at positive 1/2. That's when the numerator is equal to 0. So we're going to have an x-intercept or a root at 1/2, 0. And the y-intercept, that's where x is 0. That's going to be there's going to be none, because when x is 0, you know what happens in the denominator? It becomes undefined. So there's none. And now we just need to figure out where this graph is going to go. Alright, so this one's kind of a little weird because of the asymptotes, and there was a root or x-intercept at 1/2. So there's an intercept right there. So we have to figure out like what's happening to the left of the asymptotes, in between these two asymptotes, to the right of the asymptote. Okay? So there's kind of like there's like 4 areas there. All right, I'm going to highlight some areas. I'm going to pause and highlight some areas quickly. So I shaded these areas, and we need to figure out where the graph is in these areas. So I need to find some use some test points. All right, so in the purple area here, I want to check something to the left of like well, really to the left, I kind of know what's going to happen because of this hole is down here. I have a suspicion. But I'm just going to check like -2 and see what happens. But it's not, it's probably not going to go like through the axis because we don't have any more zeros besides a half. But just to be really conscientious, I'm going to check x equals -2 and I'm going to plug that in and see what I get. Okay, so you put -2 in there and you're going to get if you look up above in the factored form, you put a -2 in here, you're going to get a -5 over -2 times -5, which really is going to be a negative divided by a positive, so that's going to be a -1/2. It's going to be a negative number. So what that tells me is the graph is going to be down below the horizontal asymptote. So we're just checking to see where this graph's going to be at x equals -2, and it's saying it's going to be down here. So what this is going to look like, did that erase it? When I checked x equals 2, what I found out is it's going to go like this. Remember, there's a hole there, so it doesn't actually go through that. And then it's going to follow the asymptotes. Never going to get there, but it's going to go there. Okay. Now this is a little tricky. I had to check a number to the left of a half, left of a half, but to the right of 0. So for the yellow area, I checked x equals 1/4. Okay, and when I put a 1/4 in there, I got -1/2 over, and this is just plugging a 1/4 into the function. 1/4 times -2 3/4. Okay, and I didn't even really calculate if that was what that number was. I just know that it is a positive, right? Because we're going to have a negative divided by a negative, so it's going to be a positive. So what that means is this graph is going to come from the top. It's going to go through that root there. Okay? And I don't know what's going to happen until I check the red. If the red's positive, it's going to bounce back up and it's going to go up there. But I don't think it's going to bounce because the multiplicity was just 1. All right, but if I check an area in this right here, if I check 3, which I checked 3, okay, so check x equals 3, and you're going to get 3 over 2 times -1. Is that going to be positive or negative? That's going to be a negative, so then it's going to pass through and it's going to go like this, and it's going to come over somewhere and it's going to follow that. So it's going to be like a little cubic function there. Okay, so that one's going to go like that. And then to the right, over here in the blue area, I checked x equals 4. And I checked x equals 4, and I got 7 over 4 times 1, which is a positive, which means that this one's going to go something like that. So we have a point to the board, but you can't see that on recording. That's how it goes. Yeah, Hunter.
How come the middle one can cross the horizontal asymptote?
Because there's a 0 there.
Oh.
Yeah. Oh, and good point. The asymptote describes end behavior. Remember, end behavior is all the way to the right side of the graph forever and ever and ever. When you plug in a very large. Good question. Thanks for that. Good contribution. All right. Let's see. All right, so this one has no holes. We factored it already. There are no factors that cancel out, so holes, there are none. Nope. Vertical asymptotes. Are there any vertical asymptotes? -4. Good. Horizontal asymptotes. This is where we're uncharted territory. The top is bigger than the bottom now. Okay? So when the top is bigger than the bottom, we have a slant. Okay? And so our asymptote is going to be oblique. It's going to be at an angle or slant. And to get that slant, the line of that slant, we're going to have to take and divide this. Right? We'll have to divide the numerator by x plus 4. So if there was only some way that we knew how to divide by a linear, synthetic division. Yeah, because it's linear. So let's use synthetic division, and let's go ahead and just run a quick little divide there. What am I going to put in the box?
-4.
Yep, and then I'll do a 1 and a -1 and a -6. And I'll just fire it through this. Go 1 there, -4 there, -5 there, 20 there, 14 is the remainder there, over x plus 4, and that's going to be an x minus 5, okay? So when you divide that, you get x minus 5. All right, we are going to ignore the remainder part because that's somewhat negligible as you're plugging very, very, very large numbers in. So the horizontal asymptote is going to be the quotient of that numerator divided by the denominator, which is y equals x minus 5. It's the linear, it's the line x minus 5. Okay? I'm going to erase this and get this out of our way now. And I'm going to go ahead and start plotting those asymptotes. So we have a vertical asymptote at -4. All right, so I put in the asymptotes, I graphed the line y equals x minus 5, and so I have a slant or oblique asymptote and a vertical asymptote at -4. Now, any x-intercepts? Like I have 2. I have 1 at 3 and I have 1 at -2. 3, 0, and -2, 0 are intercepts on the x. The y-intercept, when I put 0 in for x, is going to be -3 times 2, which is -6. Over +4, which is -3 halves. So the y-intercept is 0, -3 halves. And now we got to figure out where the graph is. What's going on? Well, let's put those intercepts on the graph. So we have a 0, -3 halves. Right there. We have a 3, 0, and a -2, 0. So what that means now is we are going to have, we kind of have like 4 areas we're looking at. We're looking at what happens to the right of this vertical asymptote and what happens to the left of this vertical asymptote. And then, it's either going to be above or below this oblique asymptote. Well, the right side looks like it's definitely above the asymptote, right? Look at all these points we have up there. So this is going to go, it's going to come in like this. Go like that. Okay, now I need to figure out if the left side is going to be like above it, if it's going to be up here, or if it's going to be down there. So now how do we do that? Test points. Okay, test a point. We got to test a point to the left of -4. So how about -5? Put a -5 in and see what we get. Okay, -5. If I put, and I think I did this already in my little handy notes, I put a -5 in there, and I got -24. So I got -5, -24. Do you think that's below that line? I think it's a pretty safe bet that it's below this intersection point right there, right? Okay, you could check and find the intersection of what the y value is at x equals -4, but I'm pretty darn safe that it's going to be out here like that. Okay, kind of neat. Everybody good on that? All right, rapid fire, 30 seconds left. This one we factored it, just kidding, we did factor the numerator because the numerator didn't factor. So we had x-intercepts that were imaginary, so we had no x-intercepts. We found the slant asymptote because we divided the top and the bottom, we got y equals x plus 3. Notice the slant asymptote and the vertical asymptote. There were no holes because the numerator did not factor. The y-intercept was 0, -3.5. So that clued me in to find out that this area right here was below that slant asymptote. And then we tested over here on this side, and we found out that was above because it was 27, it was above.